We'll get started in about 30 seconds. Just want to give people just a chance to settle in. All right, it's 3 minutes past, so let's go ahead and get started. So welcome everybody. It's the June monthly OpenXLA meeting. We have another jam-packed agenda for everyone. So we're gonna just power right through it all, and please feel free to stop and ask questions, and if there are any, happy to answer them. I'm going to just give a brief update about the OpenXLA mention at WWDC last week, and then I'm going to turn it over to Kevin and Abhinav, who've got some exciting news for you in the world of stable HLO. We've got Mason and Yazo talking about libTPU and cloud TPU world. And then I'm going to turn it over to Eric Yang, who works in our ODML developer tools team, to talk about Model Explorer. And then we've got Elliot giving you an update on the OpenXLA documentation. All right, OpenXLA mentions during Apple's WWDC last week, there was the official machine learning research blog that Apple publishes. They had a big mention on Jackson XLA. I'm not sure if you all saw, but there are a ton of LinkedIn shares talking about Jackson XLA as a result of it. I also saw a lot of Spotify podcast mentions, so happy to kind of share that with you if you want to reach out to me, so that you can kind of take a look and celebrate with all of us the mentions that we got. All right, with that, I'm going to turn it over to Kevin Gleason to talk about stable HLO.
All right, thank you. Cool. So stable HLO v1.0 was released about a month ago now, I think. So first and foremost, thank you to everybody who contributed, who provided RFCs, RFC reviews, just everything. It's been an awesome community accomplishment we've hit here. There was a post on OpenXLA Discuss, which covered most of what I'm going to say today, but just a few reasons for why we released a 1.0. So first off, it's a statement of general completeness. About a little over a year ago, we set a 1.0 roadmap, and we have that included things like reference interpreter, the spec, dynamism, quantization. We've hit all of those and even exceeded it. We've added other things that weren't part of the initial roadmap, like composite ops, as well as new floating point types, things of that nature. The second reason is we've battle tested our compatibility guarantees on important workloads, both within Google and within the community. There are several PJRT plugins that are community-based that also rely on our compatibility guarantees, and we have shown some success in maintaining them as we evolve the app set. And then finally is to recently announced at Google I/O is that ODML is supporting sort of PyTorch on TF Lite, and that's accomplished largely using stable HLO by converting from PyTorch to stable HLO and then deploying that one. And so in order to support ODML, which has much more strict compatibility guarantees, we've extended our compatibility to be 5 years of backwards compatibility and 2 years of forwards compatibility. What this means for the community is if you have important benchmarks or any things you need to serialize or just persist, it's great to just convert the stable HLO, and you don't have to think about it for 5 years. And for forwards compatibility, this supports anyone in the community who is on an annual release cycle. You have even some wiggle room beyond the annual release cycle to target your latest release. And yeah, so beyond that, we have developer improvements to the developer experience, like Colab tutorials, pip wheels, things like that. And yeah, I think that's it for this slide. So what's left for 1.0? One of the final things we did in 1.0 was declared certain ops that were redundant or unused as deprecated or being explored for deprecation. And these are things that we're still planning. We're still providing the previous 6 months of compatibility on, but we're looking into consolidating them or removing them. These are for ops that are like dot and dot general, which represent the same thing, but dot general has a bit more broad semantics. And what happens when what we've seen in the community with these redundant ops is that you have canonicalizations in both directions. So if you look at a compilation pipeline, it'll have something like canonicalize dot to dot general. Okay, now canonicalize all dot generals that are dots back into dot, and then the same thing for all of these ops, really. And so by consolidating it into one op, we are hopefully making the compilation pipeline easier and sort of more single streamline. Yeah, another goal here is to reduce the maintenance overhead as we're extending these compatibility guarantees. And yeah, we're still in the process of deprecating these things. We will be for the next 6 months of compatibility. And so we're gathering feedback. If any of these ops listed here or in the RFC linked in the bottom right here are important to you or your workloads, please let us know. We've already started migrating some of these, and like now .general has a new method on it that's called isSimple.dot. And so if dot of it as an abstraction was important to you, you can just use that method to query it. Yeah, I think that's it for me.
All right, let's turn it over to Abhinav.
Yeah. Hey, thanks, Kevin. Thanks, Aditi. Hi, this is Abhinav. I'm newest member of Stable HLO team. It's been a little over 5 months I'm working with the team. Also, glad to be presenting to the XLA community. We are planning few updates to the Stable HLO offset that include adding new op, one op, or enhancing existing op. So let's dive into the motivation for this announcement. So these features have been added to MHL over the past few months already. Users are actually using that. Also, framework wants to leverage these features, and then there are member ops community who requested this feature to include as part of Stable HLO offset. So what these proposed changes are: add a dedicated TAN op to the Stable HLO offset, then custom call backend config to support dictionary attribute along with existing string attributes, and then make the collectives operand and result variadic to allow multiple operands. So let's take into the all three RFCs are open, and uh, uh, feel free to take a look at those and provide your feedback after the presentation. Let's take a look at one by one what these changes are. Next slide, please. Yeah, thank you. So the frameworks, JAX, PyTorch already has this dedicated TANOP, and also the backend XLA has the TANOP. Stability does not. So because of that, there are a few workaround in place. Also, we sometimes this TANOPs is expressed as a custom call, or it involves decomposing TANOPs before converting to stable HLO, or pattern matching while converting from the stable HLO. So a dedicated TANOP will help to remove these workaround in place. So if you look at the example, it's pretty straightforward example uh, for stable HLO TANOP. If you need more like details about the changes and more example, feel free to take a look at the RFC. Next slide, please. Yeah. So custom call backend config existing. So currently stable HLO custom call backend config accept only string attribute. On the MHLO counterpart do accept both string and dictionary attribute. So adding a dictionary attribute for stable HLO custom call backend config will help to reduce the take debt, because right now JAX use unregistered attribute to hold the dictionary attribute, because table HLO does not support dictionary attribute. At the same time, sometimes we end up serializing the dictionary as a string just to pass around for table HLO custom call out. So we will be with this feature, we'll be able to reduce this take debt. And if you look at the example, so the API version and backend config go hand in hand. So we'll be supporting the API version 4 to allow backend config to accept the dictionary attribute. It, it shows in an example that API version 4, and then it accept the backend config, accept the dictionary attribute. Next slide. And the third proposed changes is currently stable HLO collective ops. These ops are limited to single operand and single result. It does not support variadic operands. So supporting this variadic operand will help to easier to express horizontal scaling. So for example, all reduce op apply the reduction function on the particular inputs, and we can share the body function for several operands across in case of, let's say, for example, already. So if you look at the example, we apply the add stabilizer add, that's a reduction function, uh, and the same body computation is used for several operands to give uh, the result. So these are the proposed changes to the stabilizer offset. Next slide. Yeah, any questions?
Yeah, let's pause
So
right there to see if there's any questions for Kevin or Abhinav.
yeah.
Don't be shy.
Just one more thing to add while we're at this slide. Coming later today, we're planning on posting a Int2 RFC supporting Int and Uint2 types. So keep an eye out for that.
Perfect.
Yeah, so I provided the link to these RFCs. 3 RFCs are open, so feel free to provide any feedback, any comment, or if you have any use case that uses this feature, do let us know. Thank you.
Perfect. If you do have any questions, please do reach out. And Kevin and Abhinav, I'm sure will be happy to get back to you as soon as possible. All right, now we're going to turn it over to Yazo and Mason to go into Cloud TPU world and talk libTPUs.
All right, thanks, Aditi. Yeah, thanks. Hello, everyone. It's the first time I'm here in the OpenXLA community meeting. So I prepared the slides to introduce libTPU to you all. For those folks inside Google, this might be pretty familiar. So feel free to ask a question in the middle. Next slide. All right, so for people that have used Cloud TPU, it's possible that you might not have heard of libTPU in the past, because usually you would write TPU programs in JAX or in PyTorch or in TensorFlow, and libTPU is hidden behind the scene. So here I just used an example of JAX to show where libTPU fits in the entire stack. So user, if you're developing ML models, you would probably code in JAX or LAX or the JAX library in Python. Here are some examples. And JAX is mostly written in Python, give you Python APIs. So behind JAX, there's JAXlib, which is functions more like a bridge to convert those JAX APIs to TPU specific libraries. That's basically libTPU. So it's a mixture of Python and C++, and there's lots of OpenXLA usage in JAXlib. So once those Python JAX API gets converted to libTPU's commands, it gets to libTPU's execution. So libTPU, it's a binary. It's L format. You dynamic load it, dynamic link it in your process, and you can think of it as a TPU specific backend. So the TPU specific compiler, the XLA TPU compiler, the runtime profiler, user space driver for TPUs, communication primitives. How do you do all reduce all to all these things are in libTPU. To lower to the libTPU is a kernel driver. So libTPU opens the kernel driver to send work to the TPU, get results back from the TPU, just like operating over any Linux file systems. So that's where libTPU fits in the entire picture. You would probably just code in JAX or code in PyTorch, but behind the scenes, libTPU is really what makes the work happens on a TPU. Next slide. So here, this slide gives you a more detailed view if you've actually rented a Cloud TPU VM in GCE or GKE. So down below in the hardware level, you would have CPU, DRAM, and they talk to TPU over PCIe. On the TPU, there's a small ARM core, which functions kind of like an operating system, and the firmware runs on that ARM core, kind of to intake work from the CPU, dispatch work on the TPU, take core dumps, etc., etc. All these hardware are virtualized whenever you run in a Cloud TPU VM. The dashed line here, the dashed line to the right kind of shows the distinction between the virtualized world and the native world to the right. So in the virtualized world, you have a virtual machine monitor, and that virtual machine monitor would give you a guest OS. It can be a native GC VM or a GKE container. And in that guest OS, that's where the customer would have access to everything. You can write Python code in JAX, for instance, and the JAX lib will DL open libTPU. And the libTPU can see all the TPUs on that machine. DL open and opens those TPUs, closes those TPUs, compile against those TPUs, give you a binary, and send the binary to the TPU to execution. So that's everything that happens within the VM. And the libTPU also talks to some other machine daemons that's natively in the system container. So that's outside of the realm of the VM. So it will send telemetry, send data to the machine daemons, and we can query those data from the machine daemon. So that allows us to have better debuggability and even actively reach out to the customers to say, hey, you may have a problem there. So that's the role of libTPU in the overall picture. Next slide, please. Yeah, so that's the role of the libTPU, where it fits in the overall stack. So to introduce TPU to you all, I can talk a little bit about what it really is and what's inside of it. So you can kind of think of libTPU as NVIDIA's CUDA or Nicole, or AWS's Neuron. So it's basically a library that you really need to access these accelerators. So without these libraries, you can't use these accelerators. It's just operating on bit streams. And for programmers to develop their own frameworks or develop their own tools, you have to have some libraries like that. It runs if it runs on the CPU and commands the accelerator. So whenever your mother process some mother process invokes libTPU runs attached to that process, and then it drives the execution. It can compile work against the accelerator and send work to the accelerator. So the simple execution model is compile, send the work to the accelerator, execute it, and wait for the result to come back. Either the result is a success, a data buffer, or it's an error code. So at the high level, that's what it is. Next slide, please. Yeah, so interface-wise, so we're in the OpenXLA community, so many of the notations here are pretty familiar with you all. So for compile, the libTPU's interface is stable HLO or HLOL. Historically, it's been HLOL, but now I think with stable HLO has its V1.0. We would like to make it speak in stable HLO more. For runtime, all the APIs speaks the PGRT interface. There's some old legacy interface we're trying to deprecate. Primarily now it speaks PGRT. So it provides these interface to whoever it's called, whether it's JAX or PyTorch or TensorFlow. So you can you can play with it in this way. You can kind of in JAX program you can say JAX.compile, give it whatever computation graph, and .lower. So that will emit a stable HLO IR. And internally, we have a tool, we call that HLO runner. We're trying to ship that to external customers. And you can feed that IR to HLO runner. So that basically is just a thin wrapper of a libTPU. And that just compiles again that IR and execute on TPU. Next slide, please. Yeah, I think we've briefly talked about that. So libTPU is a compiler and runner, runtime, and it has, because we take a compilation approach, so it has the Nicole's functionality doing communications as well. It has profile all these things. But moreover, it's for cloud customers, it's also a debugger, a telemetry reporter, performance estimator, etc. So you can actually have a binary interface to run over libTPU. You can report telemetries, etc. So you can actually see in real time through libTPU what's the tensor core utilization rate of, let's say, the 4 TPUs you own on that VM. What's the HBM occupancy rate on those TPU? How is my program doing? And we're working on adding more telemetry, so you can have more insights into the program execution. So if you're curious about, say, the data transfer rate on the TPU's ICI, or my program got stuck, which instruction is it stuck at? Has it been that way for 15 seconds? You can see those from the TPU, and the user, ideally, they should be able to see those from the telemetry we expose. Yeah, next slide, please. So there are a couple of things we're working. I'm from the cloud TPU side. Mason's from the XLA side. We're working together to have a release for TPU, for libTPU. So the release means will be a qualified functionality stability, and there's forward backward compatibility. So you can just pip install libTPU one time in your VM, and then you can use whatever framework. You can use PyTorch, you can use JAX, you can use TensorFlow. everything on that, just using that libTPU, and it's qualified against all these use cases. The qualification would primarily be done in HLO or stable HLO, so that's the IR speaks. And on top of that, you can use whatever language JAX or PyTorch exposes. And of course, because JAX, PyTorch, TensorFlow, these frameworks are the customers of the LibTPU, so we would have end-to-end coverage, and hopefully the performance will be guaranteed as well. I think and anyone using Cloud TPU wants to have its performance or price advantage. So we'll hope in production environment, any performance degradation can be explained. Next slide, please. So we're also working on what we call libTPU SDK. So, and that will give customers self-serve diagnosis capability for their program. They can, they can basically, when they execute a JAX program or PyTorch, where they can dissect into different steps. If they're curious, they can dump an IR and execute that IR. They can extrapolate performance on different slices, different pod sizes, different TPU generations using that IR. And in the middle of the TPU execution, if something breaks, the TPU would normally give you a snapshot of the chip's architecture states. So you can analyze that architecture states. So the customer can have insights on these things. And that would also allow us, as first-party developer, to actively reach out to the third-party users so we can prevent issues ahead of time and enhance user experience. Yeah, so stay tuned. Some of these things will come in the second half of the year. Yeah, with that, I'm happy to take any questions.
Awesome. All right, so let's pause to see if there's any questions, but thank you. Great job. All right, then let's keep moving. Eric, I'm going to turn it over to you to talk about Model Explorer.
Okay. Hi, everyone. My name is Eric. I'm from ODML Developer Tools team. So today I'm going to talk about Model Explorer. Let's start from the pain points. The current visualization tools cannot visualize large graphs and cannot render it with the SVG-based solution because currently LLM can be too large for the graph. And there is no hierarchical information. So if you want to map your graph back to your upstream, it's the information is sort of lost, and it's really hard to map the node to which function call it is from. And third is there is no MIR solution right now for the visualization. So we built this Model Explorer, which is a powerful debugging tool that offers an intuitive and hierarchical visualization of large model graphs. And it uses the GPU rendering, so you can see it's very smooth and it can expand to very large and you can shrink to very small without lags. And next slide, please. And how it works. So today I'm gonna mainly focusing on the MIR-based adapter. The adapter means the backend implementation of how to visualize the MIR format. So we can divide that into two parts. The first part is the MIR pre-processing. So basically, you need to first register the dialect. Currently, we registered TF, TF Lite, Stable HLO, VHLO dialects into the Model Explorer by default. And you can easily add new dialects. And the second step is to use to add some passes. For example, if we want to translate TF executor dialect into TF for better manipulation, or if we have tf.xla call module, we want to deserialize that up and turn it into a stable HLO subgraph. So you can do that in this pre-processing steps. And then the second part is called adapter implementation. And it also has two subparts. The first part is the general one. It applies to all MIR graphs, which is like how the node and edge can be connected. This is the general for all MIR. But there is some dialect-specific implementation if you want to add more formats or dialects to it. So different dialect may have different way of storing the attributes. So we need to figure out how to parse the attributes and turn it in, map it back to the Model Explorer graph. And the second part is the hierarchical information, which is like that. On the GIF, you can see the hierarchical clicking. The way we can do it is to go into the location. When you enable the debug info, it will should give you the location information of that op. Then we can use that information to construct the hierarchical structure of the graph. So yeah, next slide, please. I can do a live demo, but I don't know, Aditi, is it okay if I do the live demo or just click on the video? Okay, let me do a live demo then. I think it's
That'd be
more
great.
interactive that way.
Yeah, love it.
Okay, thank you.
I'm going to stop sharing, and then I'll let you
Okay.
share your screen.
Awesome. So this is a sample JAX MNIST model that I created, and I turned it into MIR. So this MIR has both TF and stable flow dialect ops. And you can see the adapter is MIR adapter. So if I clicked view, it's going to pop up very soon. So in the main graph, it's a TF dialect graph. And if there is TF XLA call module op, then it will deserialize it automatically and turn it into subgraph. So in this case, we've already done that. And here it's this node will connect to the inner subgraph of this model. And let's jump into it. So this is the hierarchical, it has a hierarchical structure, and all these nodes are in stable H-low dialect. You can see, and it's very smooth. So if we click on one of them, you can see the attributes information are shown on the right side panel. Maybe it's too small. On the right side panel, and you can click onto the input and output to see their connection with different with their adjacent nodes. And you can do search in this search bar. There's for example, dot general, and you can locate to where this dot general is located in the hierarchy, in the corresponding hierarchy, and here it's the similar things. And also we've made it to show the JAX op attribute. So if there is JAX related information storing in that MIR, then we'll show it as this special field called JAX op attribute. And we've made some cool features to overlay the op node information onto this graph. So normally you would see a node without any information, but if you toggle these two buttons, then you can see the attributes are automatically displaying on all of the nodes, as well as the tensor shape and data type onto the edges. And you can easily expand and collapse your graph. And one cool thing is you can also flatten them out if you want the Neutron-like experience. So it will remove all the hierarchy and show the entire graph in one view. And we've made this enable input and output tracing. So if you enable it and click on one of the nodes, you can see how it's it only shows up the nodes that connect to this node and outputting from this node. So switching to another one, you can see here everything irrelevant nodes will be hidden from the graph. So yeah, this is a glimpse of our current MR adapter solution. Hopefully it can help you debug and develop your program. And oh, I just closed it, sorry.
Oh, that's okay.
Okay, let me continue. So yeah, you can give it a spin. We have a GitHub repo, open source version available. It's easy to download. You can just pip install this this package and just run the Model Explorer. And it will open up the same same tab that I just opened. And there are some more instructions on how to use this tool in the user guide. So any questions, any feedback? You can also share your feedback in our in the link below. So yeah, we're happy to take any like feature requests, anything.
We've actually been looking at Model Explorer. We have this thing called HLO Dev. I can talk with you more offline.
Okay.
But it looks like you're doing open source development entirely, right?
Yeah. So yeah, this entire backend is open source.
Yeah. Okay. Would love to catch
Yeah. Sounds good. Yeah. Thank you very much. Let me stop sharing.
Perfect. Oh, wait, Jez got a question.
Oh, yeah, sure.
Go ahead.
Yeah, this is great. Thank you for showing this. So, what input formats does this take? I saw in the repo it shows TF Lite formats. Does it take?
Yes, currently it consumes TF Lite flat buffer and saved model, TF saved model, as well as the MIR with TF Lite, stable HLO and VHLO dialects. And also, PyTorch exported program is also supported.
Got it. Thank you.
Yeah, no problem.
Does it natively take HLO or you have to first convert it?
The HLO like serialized.
Yeah.
It doesn't. But yeah, we can
talk.
discuss more.
Okay.
Discuss more. Yeah, because I would like to expand the format support as well.
Sounds good. Thanks.
Any other questions? All right. Thank you so much, Eric. And I'm going to turn it over to Elliot to give you an update on the documentation initiative for OpenXLA that we have underway. All right. So one of the things that if you do have feedback, please do provide that. Really, what we're trying to do is make sure that the documentation is it's suited to your needs and you have what you need. So that's really the goal of it. What I'll do is when I send out the notes and the recording in a few days, I'll make sure that we include a survey so that you can fill that survey out for us, and then you can it's a way for you to provide feedback so that we can keep improving. All right, that's all we've got. Are there any questions for any of the presenters? Great job to all the presenters. You did a fantastic job presenting. All right, just a few other things to note. I know that we've moved this to the third week of the month. That's because OpenXLA DevLab was later in April. So all of the meetings got pushed out. If you all want to move it back to the second week, just make sure you chime in and let us know and we'll go ahead and do that. Otherwise, we'll continue on with having these monthly meetings during the third week of the month, if possible. And then there is a new Google Meet link. I sent that out a few weeks ago, but I know that people have to accept the invite for it to be able to show up on their calendar. So please do accept the invite so that it shows up on your calendar and let your other teammates know that there is a new Google Meet link. It's already updated in the meeting notes doc, but if you can just highlight that for them, that would be awesome. And if there's no further questions, we will see you another couple more weeks. Thank you so much, everybody. I should start playing music at the end.
Thank you.